Hi, welcome to Module 14, Regression Analysis. So in this module, we're going to talk about how to use Python to do regression analysis. In finance, we are interested in predictability, and regression provides a tool for us to find out whether a phenomenon or a variable is predictable based on a basket of other variables. So there are two types of variables in a regression model. The dependent variable, denoted by y, is the object of our interest. The independent variables, denoted by x, are factors that have an impact on the dependent variable. For example, if we would like to explore what drives a stock price to change in the future, then the dependent variable is the stock price predictability. It could be 1 day, 1 month, and 1 quarter returns. The independent variables could be PE ratio, dividend yield, historical stock price performance, interest rate, and market sentiment. Remember that regression analysis only tells us about the relationship among variables, but this relationship does not necessarily imply causality. For example, a regression may tell you that there is a relationship between the stock price of Tesla and Apple, but it does not mean that the stock price of Tesla caused the stock price of Apple to change. It could just be the reason that both stocks are affected by the market sentiment. There are several types of regression, and we will cover 3 of them in this module. They are simple linear regression, multiple linear regression, and logistic regression. A simple linear regression explores the linear relationship between two variables by finding the best fit line between them. A model can be written as y equal beta naught plus beta 1x plus epsilon. Y is the value of the dependent variable, x is the value of the independent variable, beta naught is the intercept of the best fit line, which is predicted value of y when x is 0. Beta 1 is the regression coefficient to measure the impact of 1 unit change of x on y, and epsilon is the error of the model. Take the price of an apartment as an example. Y is the average price per square foot for an apartment. X is the floor of an apartment. Beta naught is the average price per square foot when it is located on the ground floor. Beta 1 is the change in the average price per square when an apartment is located one floor higher. Epsilon is other factors that affect the average price per square. Taking the capital assets pricing model of Apple as an example, Y is the quarterly stock returns of Apple, X is the quarterly stock returns of S&P 500 index, beta naught is the absolute stock return of Apple, which is used to evaluate whether a stock is worth buying. Beta 1 is the beta of Apple, which measures the sensitivity of stock returns of Apple to the performance of the S&P 500 index. And epsilon is the shock to the stock returns of Apple with mean 0. Okay, so let's try to run some code. Here, we want to conduct a regression analysis to estimate how the stock returns of Apple is affected by the market and whether there is a positive alpha of investing in Apple from 2016 to 2021. Now we are going to import the stock prices of Apple and VOO. To do this, we need the datetime module, so we from datetime import datetime as dt, and then we import pandas data reader as ptr. Then we are going to set the period for the data analysis. So here we are going to get the data from the 1st of 2016 to the end of 2021. Next, you are going to use the data reader to read the data for Apple and VOO. Here, we are going to calculate the stock returns of Apple and VOO. First, we import numprise at MP. Then, we use ilocate ::(-1) to reverse the order of the data frame to oldest to newest instead of the original order, newest to oldest. And then, we use percentage change method to calculate the percentage change from the previous observation to the current observation. Then, we are going to use mp.array y1: to drop the first observation and convert the series of number to an array. And we use reshape -1, 1 to transpose an object. Here, we're going to do the same for VOO. VOO is a ETF for S&P 500 index, and S&P 500 index is the market index. So we would treat it as the independent variable, and we are going to see how it would affect the price of Apple. So Apple would be the dependent variable. So we set it as Y. And then we do the same for VOO here. And when you type X, you should be able to see a series of stock return for VOO. Here, we are going to show the linear relationship between Apple and VOO in a graph. First, we import matplotlib as PLT. Then, we import Seaborn as SMS. Next, we are going to use the regret plot method. This method generates a scatter plot between the two variables and shows their linear relationship from a linear regression model. Here, you should be able to see the scatter plot and also the regression line. Here, we want to add a constant to the independent variable. We import the stat model API module to help us to conduct regression analysis. The best fit line from stat model is assumed to be passing through the origin, as an intercept could exist in our model, so we have to use add constant to net the program estimate the intercept as well. Then we are going to conduct an ordinary least square regression. Here we use the sm.ols method to conduct an ordinary least square regression of y on x. Then we use model.fit to optimize the model to find the best estimate for the coefficient in the regression model. And lastly, we use result.summary to show the result of the regression analysis. Here you should be able to see the result. We got the R square, which is 55%, and also other statistics, and the most important are these two figures. So we show the constant and then the independent variables, their coefficient, standard error, t, and p-value. Let's do one more example. Now we are going to conduct a regression analysis to explore whether a higher oversubscription rate will lead to a higher initial return of a IPO. First, we are going to upload the module 14 Excel file to the platform. Then, we are going to get the initial returns and oversubscription rate from a dataset. First, we import pandas as PD. And then we are going to save the Excel file, module 14 Excel, and IPO sheet to a data frame df1. And we are going to get the numbers in oversubscription rate column and put them in X. And then we are going to put initial returns column to Y. Then we are going to conduct the OLS regression. Here we first import statsmodel.api as SM. And then you're going to add a constant to our independent variable X. And you are going to use OLS.fit to find the best estimate of our coefficients. And lastly, we type result.summary to get the result of our regression analysis. So this is the result, and you can see that oversubscription rate would definitely help to explain the initial returns. Next, we are going to conduct a regression analysis to see how the value of a fact is affected by its for. So first, we are going to read the Excel file, and then we read the property sheet to df2. And then in our model, we are going to set for as the independent variable, and then y would be the price per square foot. So here we're going to see whether an apartment that is at a higher floor will lead to a higher price per square foot. Then we also add the constant to our independent variable. And we use OLS.fit to find the best estimate of our coefficient. And we type result.summary. Now you should be able to see the result, and you can find that the 4 definitely help to explain the price per square foot. After talking about simple linear regression model, we are going to talk about multiple linear regression model. When more than one factor affects the dependent variable, we can use multiple linear regression to explore the relationship between a basket of independent variables and the dependent variable. In finance, our goal is to explore the predictability of the stock price based on a set of firm characteristics like the P/E ratio and historical stock price. Here, you can see the model of a multiple linear regression. Y is the value of the dependent variable, xi is the value of the independent variable I, beta naught is the intercept of the best fit line, and beta I is the regression coefficient of independent variable I, which is the impact of one unit changes of variable I on the dependent variable, holding other variables constant, and epsilon is the error of the model. Take the price of an apartment as an example. Y is the average price per square foot for an apartment, x1 is the floor of an apartment, x2 is a number variable which equals to 1 if an apartment is located in Wan Chai and equals to 0 if it is located elsewhere. Beta naught is the average price per square foot when it is located on the ground floor, and beta 1 is the change in the average price per square foot when an apartment is located one floor higher, controlling for the impact from the location of Wan Chai. And beta 2 is the additional price per square foot when an apartment is located in Wan Chai, controlling for the impact from the floor of an apartment. And lastly, epsilon is other factor that affect the average price per square. If an independent variable is not quantitative data like type and style, we can use dummy variable to capture their impact. The location of Wan Chai in our previous model is an example. A good practice before using multiple regression is to produce a correlation matrix to explore the correlation among independent variables. The purpose is to address the possible problem of the multicollinearity. Now we are going to conduct a regression analysis to explore how initial returns are affected by oversubscription rate, mid-market cap, and mid-offer price. Then we are going to import variables into our model. We are going to use oversubscription rate, mid-market cap, mid-offer price as independent variables, and then we are going to use initial returns as dependent variables. Next, we are going to generate a correlation matrix for independent variables to see whether there is any problem of multicollinearity. To do this, we can type correlation method, and in this case, it should be alright. So the code would be quite similar to the simple linear regression model. Here, we add constant to our independent variables, and then we type sm.olsyx. And we are going to use the model.fit method to find the best estimate of those coefficients. And lastly, we're going to use result.summary to show the result. And you should be able to see that seems oversubscription rate is the most significant independent variable, but the others may not be that important. Let's take one more example. We are going to conduct a multiple regression analysis to see how the value of a flat is affected by its floor and size. Here we're going to use floor and square foot as the independent variables and the price per square foot as the dependent variable. Then we also add the constant to our independent variables. And we are going to type ols.fit to find the best estimate of our coefficient. And lastly, we type results.summary. Here you should be able to see that both variables are important, and the higher the floor, the higher the price per square foot, and then the larger the room, the lower the price per square foot. In case the dependent variable is not quantitative but an event whether it happened or not, then we can actually use a logistic regression to calculate the probability of an event occurring based on a basket of independent variables. If an event must occur, the probability of the event must be 100%. If the event is impossible to occur, the probability would be 0%. Thus, the value of the dependent variable is bounded by 0 and 1. Another linear regression is used for quantitative data, like returns and price. Logistic regression is used for categorical data like success or fail and male or female. The logistic regression model is shown here. P is the probability of an event Y occurring given the value of all independent variables. Let's take the passengers on the Titanic as an example. Y is the survival rate of a passenger on the Titanic, and Xi can be factors like gender, age, and ticket class. Take that default as an example. Y is the probability of default within the coming 1 year, and Xi can be factors like credit rating, bond yield, and interest coverage ratio. Let's take one more example from startup. In this case, Y is the probability of going public within 3 years, and X could be factors like total fund raised, the growth of users, and operating history. We would like to explore whether the survival rate of passengers in the Titanic is related with their age, gender, and age. And here is the data source that we get the dataset. Here, we are going to create our third data frame. Here, we are going to read the Excel file, module 14, and we are going to get the data for Titanic. Then we are going to drop our observation with null value in either survived, age, and sex column. And lastly, you are going to convert sex to a dummy variable, whether male equal to 1 and female equal to 0, by using the apply method and also the lambda. So here you can see that we set 1 if x is male and else, then the variable will carry a number 0. Then we are going to set gender and age as the independent variables. And then we are going to use whether a passenger survived or not. It means survived column as the dependent variable. Lastly, we still need to add the constant to our independent variables. Then we are going to conduct the logistic regression of y on x. Here, we use the logis method. And then we're going to use model.fit to find the best estimate of our coefficient. And lastly, we are going to show the result. Here, you should be able to see that both gender and age are able to explain the survival rate. It seems that female has higher survival rate and elderly has a lower survival rate. Okay, so that's all for module 14, regression analysis. And I hope that after this module, you will know how to use Python to do regression analysis. If you want to do some practice, you can try to do the following exercise. So thank you for coming today, and I'm looking forward to see you in the next module. Have a good day. Bye.